page 202 in your textbooks. And go ahead and have your homework out. We did the review, numbers 16 and 18 at the bottom of page 202, and then a little further up at the end of the practice section. Practiced with some negative exponents on numbers 32 through 39. And then also on page 204, which we'll get to in a moment, did several review problems there, numbers 5 through 8, 11, and 13 through 16. Let's go and take a look at all of this together, but we're going to start at the bottom of page 202 with numbers 16 and 18. And for number 16, what did we have to do to multiply there, Lana?
Just double distribution.
Good, double distribution. And so we're going to distribute the x all the way through. Notice there's no gaps in the dissension. Then we're going to distribute the 1 all the way through. Everything's going to line up as long as we just shift that one place over. And then we're going to add all the like terms together to get what final answer?
X to the fourth, positive 6x cubed, positive 9x squared, positive 24x, positive 20.
Great job. X to the fourth, positive 6x cubed, positive 9x squared, positive 24x, positive 20. Then number 18, what did we have to do, Joshua?
Triple distributing.
Yeah, we're stuck triple distributing. So again, there's no gaps in the dissension at least, so that's the nice thing. So we'll distribute the x squared all the way through, shift over, distribute the negative 3x all the way through, shift over again, distribute the positive 2 all the way through, and then add all three partial products together. Let's jump straight to the final answer here, Josh. What did you get?
X to the fourth, negative 8x cubed, positive 11x squared, positive 8x, negative 12.
Perfect. Every sign, every number, every exponent, x to the fourth, negative 8x cubed, positive 11x squared, positive 8x, negative 12. How many others were also perfect on that one? Joshua was the only one. Does anyone need to see it worked out? Anyone want to see it worked? All right. So a couple of you. Let's go ahead and take a look at this here.
Is that
Number 18. Does help to know which problem we're on. So let's start with the x squared and distribute it all the way through here. Dylan?
X to the fourth, negative 5x cubed, negative 6x squared.
Good. Then let's distribute the negative 3x all the way through. Lana?
Negative 3x cubed, positive 15x squared, positive 18x.
All right, and then Adam, notice we're going to shift again, distribute the positive 2.
2x squared, negative 10x, negative 12.
Good, and then when we add all the partial products together, x to the fourth has no friends. These have the same signs, add and keep the sign. Here, combine to get a positive 17, put that with the negative 6 to get the positive 11. Here, opposite signs, subtract, keep the sign of the greater, and then no friends there.
Wait, where'd you get negative 5x cubed at in the end?
Well, right here, the x squared times the negative 5x, sign is negative, numbers 5 letters, x cubed.
I forgot to distribute the 2.
Oh.
So you only did the first 2 distributions. Okay, so we figured out what's going on, what went wrong for us. All right, questions on it. Great job on that, Joshua.
It was just that negative sign that threw me off.
All right. Let's go and look further up the page. And speaking of negative signs, we talked about negative exponents. In class, we said all a negative exponent means one word.
Sign.
Reciprocal. That's all a negative exponent means is reciprocal. Now, practically speaking, reciprocal means if it's up, move it down, and if it's down, move it up, right? Move it where it ain't, okay? So that's a practical way to think of it. But on number 32, we have a 2 cubed, x to the negative second, y. How did you adjust that so there were no negative exponents? Adam?
8y over x squared.
Good. We're going to go ahead and cube the 2 to get the 8. We're going to leave the y where it is, and the 8, by the way, stays where it is because there's no negative exponents there. But the x to the negative second means the reciprocal of x squared, meaning I have to move x squared down to the denominator. Great job, 8y over x squared. How about number 33, Dylan? What do we get for that?
A cubed c squared over 16.
Good. The a cubed and the c squared don't move. They don't have negative exponents, but the 4 does. So we're going to take the reciprocal of 4 squared, which means 4 squared goes to the bottom, but we can simplify 4 squared to get 16, hence a cubed c squared over 16. How about number 34? What do we need to get there, Joshua?
A cubed over 4.
Good, the 4 does not need to move because its exponent is technically a positive 1, but the a has an exponent of negative 3, which means that has to be the reciprocal of 1 over a cubed, which means a cubed in the numerator over the 4, which remains in the denominator. Great job. Number 35, Lana.
1 over x cubed.
Fantastic. The 4's are going to cancel cleanly, so it's really just x to the negative third, which means the reciprocal of x cubed, which is 1 over x cubed. Fantastic.
35.
On number 35.
Really?
The 4's cancel.
All right. I should
Oh,
know that. I
so
put
the
4
x-
over 4.
And then the x to the negative third becomes an x cubed in the denominator, and we leave the 1 in the top.
Right.
All right, I was like, does your book have a different problem than mine? Because I thought I explained it fairly clearly. All right, we're good now. We just lost track of the 4's there. All right, number 36, Dylan, we've got a negative 1/2 to the negative 4th power. And some students would be like, ooh, negatives cancel. Whoa, hold on now. The negative in front of the 1/2 means less than 0. The negative in front of the 4, because it's a negative exponent, that just means reciprocal. So I'm going to take the reciprocal of negative 1/2 to the 4th. What do we get for our answer?
16.
Positive 16. We're going to take the reciprocal of negative 1/2 to the 4th. Or in other words, negative 2 to the 4th, which is a positive 16, because a negative to an even power class gives us a positive. Good. On number 37, what do we get for our answer there, Lana?
1 over negative 8 squared.
Good. Initially, we'll take the reciprocal of negative 8 squared. But we know we can square a negative 8 to get
64.
a positive 64. And of course, a 1 squared just remains a 1. So we end up with 1/64th when we finish the simplification there. How about number 38, Joshua?
1 over 216.
Good. We're going to take the reciprocal of 6 cubed. Well, the reciprocal of 6 cubed is 1 over 216. Good job on your multiplication there. What about number 39, Adam? 5 to the negative 2nd.
1 over 5 squared.
Good. 1 over 5 squared, which becomes 1 over... What's 5 squared?
1 over 25.
1 over 25, or 1/25th. Our answer. Good job there.
I think I missed 36. I don't like.
Does it make sense now, or do we still have a question on it?
Kind of still have a question.
Right, so they started us with a negative 1/2 to the negative 4th. And of course, Lana, we know that that negative right there is in the exponent means reciprocal. So I need to take the reciprocal of this. Hence, the reciprocal is negative 2 over 1. And now that I've taken the reciprocal, the negative exponent goes away. It's just a 4. So I'm going to raise negative to the 4th power. Well, that's an even exponent, so it becomes positive. 2 to the 4th is 16. And of course, 1 to the 4th is just 1. We don't really bother with the 1 because we're lazy, and that's where the positive 16 comes from. Does that make sense now? Any other questions on this page of homework? 32 through 39 in the practice, or the review 16, 18?
I got them on right.
I got half of it wrong.
All right, so just reducing down, okay? All right, any other questions, comments? Yes, sir?
Well, I just missed number 35.
Okay, and it makes sense now when the 4's canceling? All right, same
I
thing?
didn't know the 4's canceled at first.
Well, because 4 divided by 4 is
Yeah.
1, technically. I mean, I don't really think of it as canceling, because it's a lazier way just to cross them out instead of writing a 1, but...
Didn't I got number 7 wrong? I forgot to put the X on.
7.
37
Not-
here?
Yeah.
Okay, I was about to say, number 7 wasn't
Yeah,
part of this homework. That was on page 204. We ain't got there yet. All right, questions? All right, flip over to page 204 then. Just another page over, and let's take a look at the review, 5 through 8, 11, and 13 through 16. Number 5, we're multiplying. And I've got a few monomials there. What are my 3 steps, class?
Sign number letter.
Sign, number, letter, same steps as monomial division, right? And when we multiply, we get what, Dylan?
Negative 56x squared y squared.
Cubed, y cubed, negative 56x squared, y cubed. It should have been our answer. How about number 6, Lana?
12x cubed y cubed z to the 4th.
Perfect. 12x cubed, y cubed, z to the 4th. Number 7, Joshua.
64, x to the 8th, y to the 6th, z to the 16th.
Good. 64, x to the 8th, y to the 6th, z to the 16th. How about number 8, Dylan? Oh, wait, I already called on you. Joshua. He's Joshua. Adam, I'm really struggling. I got like 2 hours of sleep last night. I had a sick kid. Stay away from me. I'm contagious. You're okay, Scott. All right, number... He's like, glad I'm on the other side of the world. Number 8, Adam.
81, a to the 12th, b to the 8th.
Great job, and that is a positive, which he left understood, which is fine, but 81, a to the 12th, b to the 8th, great job. Number 11. If I solve it the way it's written, it looks like I should do what, class?
Doubles.
It looks like I should triple distribute, right? Because there's 3 terms in that first polynomial. What I could do, since I have to write it down anyway, is I could remember that multiplication is commutative, and I'm going to put the x minus 3 in the front, and I'm going to slide the 2x squared plus 3x plus 7 to the back. Does that make sense? I can flip-flop the order of the factors, and by doing that, I now only have to double distribute. I only have to multiply an x and a negative 3, which is a lot easier than multiplying a 2x squared, then a 3x, then a positive 7. Right? It's just fewer steps, if you will. Now, technically, if you left the x negative 3 here, you could still double distribute, but you'd have to go backwards like this. Does that make sense? So let's do that. X times 2x squared,
2x cubed,
x times 3x,
Positive
3x squared,
and x times 7.
Positive 7x.
We're still going to shift, and now we've got the negative 3 times 2x squared,
Negative 6x squared.
negative 3 times 3x,
Negative 9x.
and negative 3 times 7.
Negative 21.
And we can still add these together. Get the same answer regardless of how you did it. Even if you triple distribute it, you get the same answer. How many got this answer on number 11? All right, good. Several of you.
I did.
All right, questions on this. Does it make sense that we could just write the x minus 3 at the beginning, or distribute backwards, or I guess you could triple distribute? Does that make sense how you have multiple options here? Anyone think to distribute the x plus x minus 3 instead of the bigger polynomial? Or do we all just triple distribute?
I flipped them.
Triple distribute, you went and flip-flopped them and double distributed? All right, good. Questions, comments? Just something I wanted to show there since we don't see that very often. And then numbers 13 through 16, practicing with dividing these monomials. Again, 3 steps, class? Sign number letter, right? And of course, if you multiply like basis, class, you add the exponents. But if you divide like basis, then we subtract the exponents. And so on number 13, what should we get for our answer, Joshua?
3xy.
3xy. Number 14, what should we get, Lana?
1 over a to the 4th.
Good, 1 over a to the 4th. Now you could say a to the negative 4th, but I sure hate negative exponents. Just leave it as 1 over a to the 4th. Number 15, Adam.
4s squared over r to the 4th.
Good, 4s squared over r to the 4th. And then number 16, Dylan.
Negative 7a cubed c cubed over b.
Good, negative 7, a cubed c cubed over b. Anyone perfect 4 for 4 on those last 4? All right, questions at all? Got just a couple more of those for you. If you would, go ahead and work this very quickly. A negative 35, x to the 5th, y squared, z cubed, divided by a 7, a squared, x, y squared, z to the 4th. Again, don't copy the problem, just write the answers on your paper. We are too lazy to go recopying problems we can do in our head.
What'd you get of yours was sick? What'd you get of yours was sick?
Chloe.
Really? It's not alright, Adam.
It's got to sit there like I beat all y'all. Adam? All right, on the first one, class, sign.
Negative
Number.
5.
Now, letters we'll take alphabetically. The first letter alphabetically is A. So what do we get for my A?
Oh, bottom.
A squared.
A squared in the bottom. It's just going to stay in the bottom. All right, what about X?
X to the
X to the 4th
fourth.
and the top.
4th power in the top. Y?
Y is
Cancel. Good. Z?
Z at the bottom.
Z in the bottom. And there's our answer. Negative 5x to the 4th over A squared Z. How many have this answer on the first one? On the next one, sign.
Negative.
Number.
6.
C.
C
C cubed in the top.
D.
D in the bottom.
Put a D in the bottom. How many have this answer on the second one? Any questions on this? Clear desk except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else away. First and last name at the top of your paper, along with today's date, which is 10/15/21. 10/15/21 is today's date. And this is quiz 10. Quiz 10. First and last name. Today's date, 10/15/21. And this is quiz 10. An opportunity to start off quarter number 2 on a high note with an outstanding grade on this quiz. Again, 10/15/21 today's date. And this is quiz 10. Let's go and take a look at the quiz together very quickly. 1 through 4, just write the answers. Numbers 5 through 7, you're multiplying. Numbers 8 through 10, you're dividing. And numbers 11 through 13, let's make those look good by having just positive exponents on those. Right? Use that quiz copy as a cover sheet.
Just like we just did, right?
Everything on here is what we just did. It's the idea of quizzes generally.
Is spelling gonna count for it?
Spell it correctly.
Just about another minute or so to be finishing up. All right, we'll go and collect those from you, and we'll take a look at those in our next lesson. For now, if you would go and take out your notes, and we are going to progress kind of like we did with multiplication. We started with just monomials multiplied by each other, right? And it was sign, number, letter, and you were done. Then we progressed to monomial times polynomial, where it was distribution, right? Sign, number, letter 1, sign, number, letter twice, sign, number, letter 3 times, and so forth. We're going to do the same progression here with division, kind of taking it step by step. So the next section of your notes is dividing a polynomial by a monomial. And again, when I use the term polynomial, we're specifically referring to more than one term. So 2 or more terms divided by a single term. And for this, it's really kind of like how distribution, you would use sign, number, letter multiple times. The same thing's going to be true here. Write this problem down, if you would, under the heading as kind of an example here. 5x squared y minus 10x squared y squared positive 15xy cubed divided by negative 5xy. And when we divide by a monomial, we're going to do sign, number, letter multiple times. We're going to divide sign, number, letter once, sign, number, letter twice, sign, number, letter 3 times. Does that make sense? Kind of like we did with distribution, where we multiplied sign, number, letter multiple times. We're going to divide it multiple times. Now there's one word of caution. Don't cancel by crossing out. For instance, it would be very tempting as we approach this first. We're going to say positive divided by negative, class. Negative. 5 divided by 5. 1. X squared divided by x.
X to the first.
X to the first. And y will cancel. And in monomials, I'll oftentimes cross out the y's. Don't do that, because otherwise you lose track of the fact that the y is still here when we do the next sign, number, letter. Does that make sense?
The first one.
I could cross out the top one, I suppose, but don't cross out the bottom one, because we're going to need it for this sign, number, letter. Sign,
Positive.
number,
2.
x's,
X.
y's,
Y.
and then we go to the next sign, number, letter. Sign,
Negative.
number,
3.
x's,
Cancel.
but don't cross them out, y's,
Squared.
and there's my answer. So it's like the opposite of distribution, if you will, in that you're dividing sign, number, letter multiple times, but still pretty straightforward, I would say, right? It's just kind of like doing 3 problems in one. Let's take a look at another one. Write this one down, if you would, please. 8x squared z cubed positive 4x cubed z squared divided by 4x squared z. And again, we're going to use what 3 steps to divide, class? Sign, number, letter. So when we do the first sign, number, letter right here, what are we going to get? Dylan?
2 z squared.
Good. 2z squared. The x squares would cancel. Then when I divide this sign, number, letter, Lana, what will I get?
1 or positive 1 x and z.
There we go. And I'm done. There's my answer. So really not a hard process, at least I don't think so. Of course, I'm the teacher, so I shouldn't think so. Questions on this? I usually try to be somewhat forthright. I'd be like, yeah, if I were a student, this would be challenging, or if I were a student, this would be easy. I guess I feel like if I were a student, this would be fairly easy. Do you all feel like it's pretty easy? Okay, good. So we're not blowing anyone's brain on a Friday? Yeah, wait till Monday. I'm just kidding. Page 204 in your textbooks. Page 204 in your textbooks. I want you to practice with a few of these. On page 204, I want you numbers 1 through 9 the odd at the top of the page. Page 204, numbers 1 through 9 the odd at the top of the page, dividing polynomials by monomials. All right, let's go ahead and take a look at these problems together. Number 1, what did you get for your answer, Adam?
6x squared negative 3x positive 9.
Good. How many got the same answer? 6x squared negative 3x positive 9. Number 3, Lana.
1x squared negative 5x.
Good. 1x squared negative 5x. Same answer. All right, number 5, Joshua.
3x squared positive 4xy positive 5y squared.
Great job. 3x squared positive 4xy positive 5y squared. Seen a couple people fixing some mistakes there. Questions, comments?
I put y squared in the second term.
Makes sense. Subtracting those exponents, y cubed, y squared, giving y the first in the middle. How about number 7, Dylan?
2 positive 1b.
Good. Positive 2, positive 1b, or just 2 plus b. And then number 9, Adam?
Negative 3k squared positive k.
Ooh.
Like,
Anna?
Negative 3k squared positive 1k positive 1.
Very good. Positive 1 at the end. So as we go through sign, number, letter, we see sign is negative. Number, take us a minute, 3. Letter, k squared. Sign, positive. Number, 1, which I normally leave understood. And then letter, k. Sign, positive. Number, 1. K's cancel, so I can't leave the 1 understood because there isn't a letter with it. But we still get a 1, right? Whenever you divide something by itself, it equals 1. So, yeah, how many remembered like Lana did the 1 at the end? How many like Adam, they left it off? All right, questions on that? All right, go back and do 2 through 12, the even now. 2 through 12, the even. Don't worry, we're going to come back to 11, Scott.
Scott's always working ahead.
It's like, I want to do the hard one. Scott, that's not lazy, but it is, admirable. Admirable, if not lazy. Put down one. That's what just a little bit longer to be finishing those 6 problems. If you're finished early, go back and look at 11. See if you can figure that one out. It's pretty nasty. Some of you remember me saying how much I hate fractions. It still applies. All right, go put your pencils down. Let's take a look at these together. And number 2, what did you get for your answer, Joshua?
8x cubed positive 4x squared negative 6x.
Great job. 8x cubed positive 4x squared negative 6x. Number 4, Lana.
Negative 27a, positive 3.
Great job. Negative 27a, positive 3. Number 6, Adam.
Negative 1a cubed b positive 2a to the fourth b squared negative 3.
Great job. Negative a cubed b, positive 2a to the fourth b squared, negative 3. Number 8, Dylan.
9k negative 5n.
9k, negative 5n. Number 10, Joshua.
Negative 2x squared y squared negative 1x y cubed negative 3.
Good. Negative 2x squared y squared, negative 1xy cubed, negative 3 is correct. And the number 12, Lana.
4a to the fourth, positive 6a cubed, negative 4a squared, negative 2.
Good. We got the 4a squared, 4 to the fourth, positive 6a cubed, negative 4a squared, negative 2. Anyone go 6 for 6? You got them all right. All right. Any questions, comments on any of those? Let's take a look at number 11. And this is just obnoxious because we have fractions. We got a 2/3 x squared, a 5/6 x plus a 1/6, all being divided by 2. But you remember, going back to your junior high and elementary days, that when we go to divide sign number letter, that means that the number is going to end up being 2/3 divided by 2, right? We don't really divide when it comes to fractions. We multiply by the reciprocal, right? We don't divide fractions. We multiply by the reciprocal. So I'm going to turn this into 2/3 times 1/2, except we don't really use the x anymore. That was back in our elementary and junior high days. We use a raised dot now. And in fact, we could cancel the 2's here and get 1/3. And of course, there's nothing to divide the letter by, so we get 1/3 x squared. So here, instead of 5/6 divided by 2, let's make it 5/6 times 1/2 to get
5/12.
a positive 5/12 x. And maybe you can do this in your head. What do you get when you divide a 1/6 by 2? 1/12. Because it's 1/6 times a half.
Oh, yeah.
Gives us the 1/12. Did anyone happen to get that?
I
Good,
switched
Dylan.
it all around and I multiplied 3 halves by 2 instead of 1 half.
You made the top of the reciprocal instead of the bottom of the reciprocal.
That's okay.
Okay.
I looked up and I saw that. I was like, 2 divided by 5, and I was like, that's when I got my answer.
All right. Does that make sense now, though? All right. Adam, question, comment?
I got something weird.
Well, does it make sense why you should have gotten that?
I don't know. I got 5x over 3x squared 12.
Oh.
Oh, my. All right. Let's take a look at number 13. Now, let's do this one together, if you would. I'm going to copy it on the board. You don't necessarily have to copy it down. You can do it right there in your book. I'm going to talk through this with you. We're dividing all of this by a y squared. So, again, we're going to do sign number letter 3 times. So when we do the sign number letter right here, what do I get, anyone?
X squared.
X squared. Because the y squareds cancel, right? What do I get right here?
XY.
Because don't forget about the sign.
Negative XY.
Sign number letter. So we get
Yep.
negative 1xy or just negative xy. But then look right here at the end. Sign.
Positive.
Number, of course, is the understood one, so we won't worry about it. The letters, well, let's start with the x.
X
It just stays x. But then the y
is
It's
in
the
the
bottom.
bottom.
should be in the bottom. Not in the bottom of the whole thing.
Oh.
Only in the bottom of that one term, because there is no y in the bottom of the second term or the first term. Just a y in the bottom of the third term. Does that make sense? Because that's the only division that should have left a y in the bottom. Look at number 14. Very similar thing happens. We have the 10x cubed, negative 8x squared, positive 4x, negative 2, dividing all of it by 2x. Again, it starts out great. Sign number letter on the first class gives us
5x.
5x squared. Then the next sign number letter gives us
Negative 4x.
negative 4x. The next sign number letter gives us
Positive
Positive.
positive 2, and the x's cancel. And the next sign number letter gives us sign
negative
number
1
letter
over x.
in the bottom.
Mm.
Does that make sense? So you can still end up with stuff in the bottom, even with polynomial division, but it'll just be individual terms that may have that. Look, for instance, at number 15. This is kind of a weirdish one. Let me erase the middle stuff off of here so I have some more room. Take a moment, look at 15 while I get it written up here. And 9y cubed, negative 7y, negative 6, all over is 7y. All right, so my first sign number letter. My sign, of course, is the understood positive, right? Can I divide 9 by 7? So treat it like a fraction and reduce. Can that even reduce? So what do I do with 9 divided by 7?
9 sevens.
9 sevens. And then y cubed divided by y.
Y squared.
Y squared in the top. The next sign, number, letter gives us what?
Negative 1.
Good. It doesn't cancel, so there's nothing. It leaves us with a negative 1. And then the next sign, number, letter is going to give us what?
Negative 6, and it's over 7y.
Yeah, negative 6/7, and then y in the bottom, so negative 6/7y. Is it pretty? No. But that's just how you handle problems like those. Questions on that. Let's take a look now at number 18. Number 18, we've got a 3/4 x squared y plus 5/4 xy squared, all being divided by a 1/4 xy. And again, we know we're not really going to divide fractions, class. We're going to multiply by the
Reciprocal.
So when it comes to the numbers, I'm not dividing by a 4th. I'm multiplying by 4. So I'm going to scribble this out. I'm going to do times 4 over 1 times 4 over 1. Thoughts?
3.
3. And here the number is going to be what? 5. Now let's take care of the letters as well. Of course, here are the letters.
X.
3x.
Just x, okay? And the next sign's positive. Here are the letters.
Cancel. And then y.
Just 1. And there we go. It looks ghastly.
Wait, what about the middle? Oh.
No, it's just these, this term and this term with the multiplied by the 4 over 1. So again, even if you have a fraction in the bottom, flip it, right? Multiply by the reciprocal. Questions on that. All right, for homework this evening, you only have 2 problems to do. You have page 204, number 17, page 204, number 17, and page 204, review number 1, which is a word problem. Page 204, number 17, and page 204 in the review number 1, which is a word problem. That's it.
What was it again?
Page 204, practice number 17, and review number 1. All right, we'll take a look at that on Monday. Have a wonderful rest of your day and a wonderful weekend, and you are dismissed.